On these notes, we're going to go through these two sections, and we're going to go through them fairly quickly. One of them was page 133. That's what you were assigned last time. I'm just going back through it. These two sections, I don't want to say that they're not important, but I just don't always agree with how they do everything, how things are rounded, how just different setups. So as we're going through them, Kai, put that away before I take it back. As we're going through them, I'll probably tell you through there at some point, hey, this is, a lot of it's just common sense. Sometimes you just got to do things the way that makes sense to do it. They tell you to round stuff off or go out to certain significant figures and different things. If you're dealing with money, let's say, how many places should you go out every single time? Two places behind the decimal. No matter how many significant digits there are, no matter how it tells you to round it, you should always go out 2 places. So sometimes common sense has to take effect, or has to take control. On this, precision, accuracy, and measures. Precision, and that's what goes in here. Hopefully, I wrote with this earlier and it was working pretty well. Probably not going to work now. Precision, can you read that? Kylie, can you read that? Precision is the repeatability or reproducibility of a measurement. It depends only on the smallest unit of measure available on a measuring tool. I got this ruler, and this is in inches. It's split up this way. What's the smallest unit of measurement on that ruler right now? An inch. 1 inch. That's as close as we can get. If we're measuring with this ruler, the closest we can possibly get to the actual measurement of whatever it is we're measuring is within 1 inch. That's it. If I do that, now we can get to within a what? Half an inch. Good. Half an inch. If we do this, now we can get to within 1/4 of an inch. All right? That's all this is saying. With precision, it depends on the smallest unit of measure available on your measuring tool, whatever that tool is, a ruler, a measuring cup. Sorry, I couldn't think of the name of it. A measuring cup, anything that we measure with, a scale, if you're weighing something. It depends on how small it goes. So I've been going to the doctor quite often here last couple of months. Every time I walk into the doctor, what's the first thing they ask you to do? Get on the scale. All right, so every time. And every time I look at the scale, the last one that they had me get on, it went out 2 places behind the decimal. So it said I weighed this. No laughing, Cooper. I want to put my actual weight up here. It said I weighed this. The previous doctor before that, they had a scale, and it only went out 1 place. One of the other doctors just had a real old junk scale, and it just said this. So it just depends on what that measuring tool actually goes out to. This is just precision again. Same thing. I'm not sure why I put it on here twice. Really thought this was going to work. Ain't too bad, is it? You can tell, kind of. So precision, repeatability, reproducibility. Is it coming up the same thing all the time, over and over again? This next one, my right feels slow, I think it should have my mouth shut. I swear I tried this earlier today and it was working fairly well, and I thought, all right, I'm going to go with it. Accuracy on the fourth try. Accuracy is the nearness to what you actually want to be. So when I'm talking about my weight here, this is what I want to be. It's not actually what I am, but this is what I would have liked to the scale to have said. That doesn't really do anything, but that's the accuracy of it. Accuracy is nearness of the measurement to the true value of the actual measurement. Precision and accuracy, two completely different things. Make sure you don't get them confused. And we'll talk a little bit about how to not get them confused here in a second. So if we have this thing here, there's nothing to actually write down here, just looking at it. This top segment, looking at this ruler that we're using here in centimeters, what's the measurement of that top segment? What's as close as we can get? 8 centimeters. How about the second one? 8 centimeters. How about the third one? Now, are they all the same length? No. With precision. You might want to put an asterisk beside this one or something. This is very, very important. With precision. Precision equals 1/2 of the smallest measurement on the instrument. What's of mean in algebra? What operation does it mean? Multiplication of time. Probably, since you have a calculator, you're probably not going to use 1/2. You're probably going to use what when you're timesing this? 0.5. So with all your great eyes, somebody tell me how many little spaces are there in between any two little things there? Like 2 and 3, or 3 and 4, or 4 and 5. How many spaces? 10 spaces. All right, you probably counted the marks instead of the spaces. So there's 10 spaces. Well, what that means is each one of those spaces counts as 1/10 of a centimeter. To find our precision of this ruler, we take that 1/10 times 1/2, or times 0.5. Somebody help me out. What's 0.1 times 0.5? What's 1 times 5? 5. How many places behind the decimal do we need? There was 1 here and 1 there, so total of 2. That means if we're on this ruler, we can come to within 5/100ths of a centimeter. That's our precision. That's how precise we can be. Look at the next one. Again, we're going to take 0.5 times the smallest unit. Somebody count between 2 and 3, or 1 and 2. How many spaces? Remember, if we're dealing with inches, we talked about this earlier this year, if you're dealing with inches, a ruler with inches on it's always split up into what? We started it when I had my ruler drawn up here a minute ago. It's either got to be halves, fourths, eighths, sixteenths. That's the normal one, is sixteenths. Then it could go on to 32nds, so on and so on. So each one of these little spaces counts as how much? And I'm going to get rid of this because I messed it up. Each one of these little spaces counts as what part of an inch? If I go from here to here, what part of an inch did I go? 1/16. 1/16. So you're going to take, instead of 0.5, I'm going to use 1/2 this time. 1/2 times the smallest unit of measure on this is a 16. How do we multiply that? What do you get on top? What's 1 times 1? 2 times 16?
32.
That's how precise we can be on that ruler. 1/32 of an inch. 1/32 of an inch. So that's precision. How precise can you be? So if I'm measuring this segment, for some reason I'm starting here at 2, and I'm measuring a segment and it goes out to here. And one of you looks at it and says, oh, it only goes out to 3. The next one looks at it and says, no, it goes out to that next mark past the 3. We're still within that precision. We're still, and we're going to talk about how we can get that gap there. We're still within 1/32 of an inch one way or the other. So precision is the repeatability or reproducibility of a measurement on a target. Yeah, but you don't want to do that because the top of the
Yeah, dude.
I got 2 of them. I don't know how to do that. So if we look at these targets, you can't hardly see mine up here, but on your paper you might be able to see it a little better. The first one, what do you notice about all the dots or wherever they shot at? They're all right there in that same little clump, aren't they? That is accurate and precise, both. Right? The second one, what do you notice? They're spread out a little more. So they're not very precise, but they're still accurate. They're still all right about where we wanted to hit. How about the third one? Notice they're all right here in a little group, so they're precise. They're not hitting what we wanted to hit, right? So it'd be like if I had a if I had a gun and I was shooting at Albert Einstein back here on the wall, right? And every time I'm shooting, I'm hitting the NT banner over here.
Oh my goodness.
But every one of them's hitting the same spot on that NT banner. So I am precise, but I'm not very accurate. All right? This one, they're all spread all over the place, so what's that tell you? Not accurate or precise. So you got to know the difference between accurate and precise. Accurate, we're getting close to where we want to be. Precise just means that everything's coming out in that one sort of area. In the physical world, measurements that are always approximate. When I ask you to measure something, can you measure it exactly? It's impossible to measure anything exactly. All right? We're never going to have anything exact. And this blank, sorry, I'm trying to. Take all day trying to write this one. Approximate error. Approximate error of a measurement can help you determine how accurate the calculations can be using the measurement. So how much error is there in the measurement? That's the approximate error. To find approximate error, it's going to be this formula down here. We're going to talk about it here in just a second. Approximate error also goes in that blank. I'm going to cheat this time. So that way I don't have to try to not have it going all over the place. Approximate error is the positive difference between the actual measurement and the approximate or estimated measurement. Here's where you got to be careful. Actual measurement. This says we weigh a 10-pound bowling ball and it weighs 10.15 pounds. What's the actual measurement? 10 pounds. All right, it's supposed to be a 10-pound bowling ball. So let's say you go to the grocery and you buy a pound of hamburger. What's the actual measurement of that? 1 pound. We take it home and we measure it or we weigh it on some scale that we have, or we bring it in here to Mr. Swihart or Mr. Bryan or whoever, and they weigh it on one of their little scales, and it comes up 1.2 pounds. That's the estimated measurement. All right? I know that seems sort of like it's backwards or something, but that's the measurement you're given is the actual measurement. So here when we do this, you weigh a 10-pound bowling ball. This E stands for error. What's the A stand for? Approximate. So this is the approximate error. What's these little bars here? That one and the one on the other end. What's that mean? All right, absolute value, right? It's the absolute value. So when we do this, E sub A equals the absolute value of, what was the actual measurement? 10 minus, what's the estimated measurement? 10.15. What is 10 minus 10.15? Close. Negative 0.15, good. What's the absolute value of negative 0.15? Now, Kyle, it's just 0.15. That's our approximate error. That's how much error we have in that measure. Again, the main thing with this is this formula right here. Sorry, Keith, but it just drives me nuts how much entertainment you get just because it doesn't.
That board's not your friend.
This is where I tried it. I thought, okay, I'm going to try this. It worked out fairly good. Find this on there. There's nothing to actually write down on this. We're just going to go over it. Students often believe that the measurement with the most decimals is the actual measurement. All right? Don't think just because it's got a whole bunch of decimals in it, does that mean it's the best measurement? No, not necessarily. All right? Could mean that our tool is all messed up. Actual measurement is the true weight, length, so on, so on. The estimate is what you're taking, what you measured out. When using measurements to calculate anything, the greater your approximate error is, so the more error you have, the greater effect it has on your accuracy. Measurement error also could be due to rounding, and we're going to talk about rounding. When you're rounding, because a lot of you like to round off way too much or not enough. All right, and we're going to talk about how to round. A lot of times with rounding, this is one of the things I was saying earlier. With rounding, you got to have some common sense. When you're rounding stuff, you got to have common sense. When you're rounding something, hopefully all of you know when you're rounding. How do you know how to round?
If it's above 5.
All right, so you,
5 or more letters, 4 or less letters.
so now you got to be careful when you do this. If it's above 5, we round it up, right? If it's less than 5, 4 or less, what do? Leave it alone. Keep it the same, all right? And what that's called, when you keep it the same, it's called truncating. Sorry, this is not working out well.
Use a marker.
Truncating. Now I'm trying to record it and the marker won't record. So when you're cutting something off, because we're not rounding down, we are sort of, but when you're just cutting something off, that's called truncating. So if I took a knife and I cut this piece of paper right here, I would truncate it. That's what that word means. Right? Your calculators only go out so far. They truncate every number when they do it, because they cut it off at a certain point, 7 spots or 8 spots, however far your calculator goes out. So if we're doing this example, round 42.64 to the nearest tenth. Which number's in the tenth place?
2. I mean, no. 6.
The 6 is.
Yeah.
Which number do we look at to tell how to round it?
6. Oh, wait,
We look at the
4.
4, right? We look at the hundreds. What's that 4 tell us to do?
Keep it the same.
Keep it the same. So we're just truncating it. We're just cutting it off there. 42.6. When you round something off, that's what goes in that blank. Range when rounding. Range when rounding. Notice the range in the example above. When we round something off, what we're telling whoever looks at it next, do they think the exact measurement's 42.6? No, because we can't be exact. We just said that a minute ago. You cannot ever get an exact measurement. But Miss Vaughn back here looks at this. Michael writes down this answer, 42.6. She looks at it and she thinks, "Yeah, I trust Michael. He can measure fairly well." But she doesn't trust him completely to be exactly right because she knows he can't be exactly right. So what you're doing there, or what we're looking at, is we're saying, all right, we know we rounded to the nearest tenth. Well, if we round it to the nearest tenth, then that means the actual answer, if we were on a ruler or something, the actual answer would be between 42 point, not 6, but 42.55 up to 42.65. So that's what goes in here. 42.42 point, 42, it's not gonna let me write it anywhere. 42.55, good enough. And then this blank, 42.65. Now the reason for that, when we round it off to the nearest tenth, that means a tenth is our smallest unit of measurement. What's half of a tenth? So we take 0.5 times that, you get 0.05. All you do, that 0.05, we subtract 0.05. That's our precision number, 0.05. We subtract that from the measurement. So 42.6 minus 0.05, which gives us 42.55. That's as low as we can get. And then we add 0.05 to it, and we get 42.65. That's as high as we can get. This is our range. So going back to my original example here, Miss Vaughn's looking at this measurement, 42.6. Michael gave her this measurement. She knows that Michael isn't exact, but she has enough faith in Michael that his measurement isn't exactly that, but it's going to be between those two numbers for sure. Measurements with a greater error will have, gotta go backwards, will have a greater effect on the accuracy of calculated results. All they're saying there is, the more you round this off and stuff, what's that do to your final answer if you're using this for other things? Changes it, doesn't it? Makes it farther off. So if we had 42.6 and I told you to round it off, and some of you rounded off 42.6, and then somebody else said, I'm just going to round it off 43 because that's easier and that's what I want to do. It's going to make it less precise, less accurate. Rounding is one possible way measurements can contain error. If a number is to be rounded to the tenths, then look at the hundreds, so on, you guys know that. If the value is less than 5, leave it the same, so on. Many students believe that you can round the number twice. If I got this number, 7.45, and I tell you to round it off, a lot of students want to take the 5 and round the 4. Well, what's that 5 tell you to do to the 4? Round it up. So then you got 7.5. Well, then some students, not you, right, Keith? Some students then will go, well, 7.5, that's close to what? 8. So you rounded the number twice now. Don't do that. You round it once, so if you want to round it to the nearest whole number, what's 7.45 rounded to the nearest whole number? 7. What's 7.5 rounded to, or 7.45 rounded to the nearest tenth? 7.5. Don't round it twice. Alejandro wants to carpet his bedroom. He measures the dimensions of his bedroom and rounds the answer to the nearest foot. The carpet he chose cost $2.63 per square foot. They say he rounded to the nearest foot. Does that mean that this, we know for sure that the length of his bedroom here is 10 feet? No. Do this for me on your paper there. This is what you're going to write down. Oh, I got plenty of room here. Let me drop down here a little bit. Length. What could the length be between? He said 10 foot. So our smallest unit of measurement is 1 foot, correct?
I'm fine with it.
So what's 0.5 or half of 1 foot? What's 1/2 times 1 foot? 6 inches, or half a foot, right? So we want to go down a half a foot and go up a half a foot. So if we're at 10, if he said it's 10, what's the lowest it could actually be? 9.5 feet? Or 9.5 if you wanted to do that? What's the highest it could actually be? 10.5 or 10.5? Let's do the width. What's the range here for his width? If he said it was 8 foot, what's the lowest it could go down to? 7.5, 7.5. What's the highest it could go up to? 8.5. My wife just had hardwood flooring put down in a few rooms in our house, and we had 4 people come in and measure to get an estimate on how much it was going to cost us. All 4 of those people, when they measured it and everything, came out with 4 completely different answers. Right? One of them came out with like 700 square feet. Another one came out with 900 square feet. Another one came out with like 830 square feet. I can't remember what the 4th one came out with, but they were all 4 completely different. So I called them all back and I said, I'd like you to come re-measure it. And I measured it myself and was real precise and went around. And then when I called them back, I think like only 3 of them actually came back. I went with the one who was closest to what I got, because I knew that then that person actually had some idea what they were doing instead of just coming in there and throwing numbers around. So that's what we're doing here with Alejandro. We want to figure out carpet chosen, square foot. He measures the carpet. Doesn't really tell us what we want to figure out, so we're just going to go with it. So, if we go by the small measurements, first of all, how do you find area of, what shape is that? Rectangle. What's the formula for area of a rectangle? Length times width, base times height, whichever one you want to say. So let's use the small numbers first. Grab your calculators out and help me. What's the length of his room if we're going with the small end? 9.5, 9.5 times, what's the width? 0.5. Somebody do that multiplication for us. 71.25. Don't forget that this is in square feet. So his room could be 71.25 square feet. That's how much carpet it could take. That's the low end. What's the high end? How are we going to find it? What's the length if we're on the high end? 10.5 times 8.5, good. Somebody multiply that for us. 89.25?
Yep.
Anybody else get that? So that tells us that the area of his room should fall somewhere between 71.25 and 89.25 square feet. Now they gave us a cost. What could we do to figure out how much it's going to cost him? What would you do with that $2.63? So multiply it. So let's do that. I'm going to jump down here and I'm just going to write cost. I'm not actually going to show the multiplication. You're going to take 71.25 and times it by what? 2.63. Somebody do that for us.
187.3875.
0.3875. It's money, so rounding, $39. So $187.39. That's the lowest it could cost him. How are we going to figure out the highest it could cost him? Take 89.25 and times it by 263, right?
234.73.
Let's round it off. Is it already rounded?
Yeah, I just did.
So when the people come in, they carpet his bedroom, and they charge him $320, what should he know?
His measurements wrong.
Hey, something was wrong. All right? Either he measured wrong to start with, or they overcharged him, and he needs to figure out, hey, what's going on here? Why is it more than I thought it was going to be? Significant figures. You guys, any of you do significant figures in science class yet? Not yet. Allows you to maintain a correct level of precision. That's supposed to say precision. When you're working with your measurements. The significant figures, pretty funny that I'm trying to touch it real lightly and stuff, and it's not doing any good that I keep doing it. Significant figures or significant digits means the same thing. Of a number are the digits that are used to express a measure of, or a measure to the appropriate degree of accuracy.
Try to write kind of harder.
That's what I need to do, because you see, like I said, I'm trying to write really, really soft, and it's not working. Then I need to try something else instead of. That's what Einstein, one of his great sayings was, doing the same, being, gotta think how to say this, being unintelligent is doing the same thing over and over again and expecting something different to happen. So I'm doing the same thing over and over again and expecting it's going to be different. I should know better. So reporting that a segment AB is 4 centimeters, is less precise than reporting and telling someone that segment AB is 4.1 centimeters. Again, with that, if Kendall tells me that this AB is 4 centimeters, then with her, we know that her measurement is between like 3.5 to 4.5. If Cooper tells us that his measurement, when he measured the segment, was 4.1, then we know that the actual measurement is between 4.05 up to 4.15. Which one is more precise? Which one's going to give you the more precise measurement? Right? His is more precise. It's just he went out a little farther. And that's just sort of common sense, right? The more, if we put 4.1, well, somebody else might put 4.13. That's even more precise than 4.1. And you could keep going and going and going. Now, Sean, he doesn't want to keep going and going and going because it's too much for him to write, right, Sean? Can't handle all this math writing stuff and everything. On this one, rules. The rules, and we're going to write down some stuff over here underneath these numbers. The rules for significant digits or significant figures. And if you do it in science class, they're more creative than I am. They say like sig figs, and it sticks in everybody's mind. I don't know. Any non-zero digits are always significant. So if we're looking at this one, how many of these numbers are non-zeros? Is that a zero? That a zero? That a zero? So how many of them are significant? 3. So we have 3 sig figs. 3 significant figures in that number. All 3 of those are significant. In whole numbers, zeros are significant if they fall between non-zero digits. So that 0 is significant if it falls between 2 other things that are not zeros. So how many of these numbers actually matter here? How many are significant?
All 4.
All 4 of them. And a decimal, numbers greater than or equal to 1. So in other words, you got a number out to the left of the decimal. Every digit is significant. So if you have a number like this, every one of the digits is significant. So how many digits do we have that are significant here? So 3 significant figures. I'm actually writing well. Not writing it out. Kylie, will you grab that for me? In decimal numbers less than 1, the first non-zero digit and every digit to the right are significant. So we look at this. In decimal numbers less than 1, that means there's no number out to the left. Thank you, Coach. There's no number out to the left other than 0. The first non-zero digit and every digit to the right are significant. Which number is the first non-zero digit? 2. And every number to the right. So how many numbers? 2. This one only has 2 significant figures. This is one of the things I said at the start. I don't agree with that. Does this 0 tell us something? Yeah. If it's not there, completely different number. Does this 0 tell us anything? Sort of. The only reason that we have that 0, if you have your calculator out, the real reason that we have that 0 is because of this. And I've had a few of you come up here and write on the board earlier this year and stuff, right? I think Cooper was one of them. He came up and wrote on the board for us once, and he did this. It's supposed to be a 5 and a 7 and a 3. What did he do at first? The point. I think Keith did this once because I said make your point what? Bigger. The only reason that we put this 0 out in front is so that you don't lose the decimal, so that the decimal doesn't just go away and you forget about it. And your calculator is the main reason for that, because if you look on your calculator, if that 0 is not there, most people don't even notice that you have a decimal because it's so small on the screen. But I don't really agree with this one because I think this 0, I think it is significant, but they don't count it as significant. And we're not going to go into that a whole lot because in math, what matters is, again, using common sense to round stuff off and deal with the numbers. How long is this top segment? By the ruler on here. And this might not be on your paper. I think I left it off. Forgot it. Just look it up here. How long is this top segment? 6. About as close as we can get. How about the second one? can we really say 6.5? Because our ruler only goes by whole numbers, right? So it's about 6, about the third one. How long is it? 6. All right? Closest we can get, 6 on all those. Notice that the exact length of each segment above is between 5.5 and 6.5. So that's our range. Got to be able to find that range. When we measure these, Kylie measures them. We don't know, and she says they're 6 centimeters. We know that she's not exactly right, but we know it's got to be between 5.5 and 6.5. We have that much faith in it. Notice that there's each segment 2 significant figures. The 5.5, 6.5, they each have 2 significant figures. Finding the range. Watch closely. Make sure you do this correctly. This first ruler is in inches. How long is our segment? One and a half. 1.5 we'll say. 1.5 is probably better, but we'll go with 1.5. Now let's go with 1.5. Now, we want the range of the actual measurement. How long it actually is. Is it 1.5? Is that exactly right? And that's just what we're going to go with? There is no such thing as being exact, right? So we want what it could be, the highest it could be, the lowest it could be. So what's our smallest unit of measurement on this rule? What did we split each inch up into? Quarters, fourths? And we want to times that by 1/2 or 0.5. What's 1 times 1?
There you go.
4 times 2? So our precision number is 1/8. We can get to within 1/8, too high or too low. So down here on this side, we're going to subtract 1/8 off. On this side, we're going to add 1/8 to our measurement right here. What we guessed it was, or what we said it was. What's 1.5 minus 1/8? Anybody know how to do that? Takes 1.5 minus an 8. How many eighths are there in a half? 4. What's 4/8 minus 1/8? So 1 3/8 inches. That's as low as it could be. If we want to add 1/8 to it, what's that going to give us? What's 1 plus 4? So 1 5/8 inches. That's our range. We know the actual measurement's not exactly 1.5, but we know for sure that it's between 1 3/8 and 1 5/8. What's the smallest unit of measurement on this rule?
Wait,
Is it 1 whole?
no.
0.1. And we're going to take that 0.1 times 0.5, or 1/2 again. We've done this like 3 times today. What's 0.1 times 0.5? You're right, good. I'm not messing with something. 0.05. And all we're going to do to get the actual measurement, or the range for the actual measurement, let's measure it first. Well, I guess I should have done that from the beginning. How long is our segment?
2.2.
2.2. Everybody agree with that? Something close to 2.2. What if we have 2.2 minus 0.05? What's 2.2 minus 0.05? 2.15,
2.25.
2.25 centimeters. Again, all you're doing here, Kendall told us it was 2.2. We know that she's not a complete and total idiot, so we trust her, but we know that she's not exactly correct. But we do know her measurements in that range. Addition and subtraction. Finding significant figures when you're dealing with addition and subtraction in your answer, or for the answer of addition or subtraction. When using addition or subtraction, the calculation cannot have more digits to the right of the decimal point than either of the original two numbers. So all this is saying, you look at your original two numbers, and you take the one with the least amount of digits, and that's how you round off your final answer. Somebody add this for me. What's 73.654 plus 45.1? Now what they're telling us is we need to round our answer. How many places did this number have behind the decimal?
3.
3 here. How many on this one?
1.
So we want to leave how many places behind the decimal in our answer?
1.
All right, just that one. So 118 point, what's this going to round off to? 118.8 would be our answer there. Again, when we're doing rounding and stuff, use common sense. If this is money, do we want to round it off to 118.8?
No.
I teach, one of the other classes I teach is transitions class. If they write down this answer, it gets marked wrong. Because most everything we deal with deals with money. And I tell them, if you don't know how many places are behind the decimal in money by now, by the time you're in high school, I feel really, really sorry for you. All right? I feel more sorry for your parents or whoever, because they're going to be taking care of you for a long, long time if you can't figure out that when you write money out, it's not $118.8. It would have to be a 0. So use common sense. This one wasn't dealing with money. They didn't tell us about money, so we just rounded off that way. That's for addition or subtraction. So whichever number has the least amount behind the decimal, that's what you go by. That's where you round it off at. For multiplication and division, somebody help us out and multiply these two.
$27.8656.
8656, is that right? When using multiplication or division, the number of significant figures in the final product or quotient is determined by the original number that has the fewest number of figures. So we look at this. How many significant figures in this one? How many in this one? 4. Which one has the fewest?
3.
So that means here we want how many significant figures?
3. No.
That's right.
Yeah.
2, is that a significant figure? 7?
Yeah.
We need one more, right? So what are we going to do when we round this off?
9.
That's what they're telling you. If you're doing significant figures, we'd round that number off to 27.9. I really don't agree with this one. I don't like this rule. If I start off with this number and this number, how many places behind the decimal in this number? And 6.18. How many to the right of the decimal? How many in this number? What I usually do, if this one has 2, that one has 3, that probably means we want to go out at least that far, so I would go with the 2, and I would round this off to 27.87. If you write down either one of these two answers, I probably wouldn't mark either one of them wrong. But with significant figures, that's the answer that they're saying that's the way it should be. And again, I don't completely agree with that. Find each measurement. Volume 837.24. Have your calculators out again so we hurry up and get through this. Be done with this. 837.24 minus 276.516. Dang. Got almost all the way through it before it started doing it. I was doing something right. Sean, what was I doing that made it go right? Somebody subtract that for us.
560.724.
562.724.
560 point.
Oh, 560.
I keep messing up the decimals. 724.
560.724. Is that right?
Okay.
Now we're subtracting here. We want to round it off using the correct number of significant figures. What they tell us in the subtraction rule? Addition, subtraction, what did it say? It says digits cannot have more digits to the right of the decimal than either of the original numbers. How many places to the right of this decimal? To this one? So what should we round this one off to? How many places? 2. What's that 4 tell us to do to the 2? So our answer is 560.72. Area of this rectangle. How you gonna find the area of that rectangle? How you find the area of a rectangle? Length times width. What's the length this time? 2 and a what? 2.5. What's that going to be as a decimal? 2.5. 2.5 times. It's supposed to be 2.5. What's the width this time? 4.25. Good. 4.25. Somebody, I don't know why. Somebody multiply that for us. Help us out. 2.5 times 4.25. If you can't read it.
10.625.
10.625. And our units are going to be inches squared. Ignore all that. Come out here. Let's do it out here. Maybe I can write it out here again. We were multiplying what the multiplication rule said. The one with the fewest significant figures, right? How many significant figures did 2.5 have? 2. 4.25. So we want to go with the one that has the fewest, which is 2, right? So what if we only want 2 significant figures? What are we going to round that off to? 11. Again, I don't completely agree with this. If we're doing significant figures, our answer should just be 11 inches squared because we're rounded off to just 2 significant figures. I would probably rather see Michael put down an answer, maybe something more like this, 10.6 inches squared. But if it was on the EOC test and they were dealing with significant figures, that's the answer they would want. I think that's rounding it too much.
This is so close, like 10.5, that it really can't be. I mean, it is, but it doesn't make sense.
Flower garden. The world's second largest flower garden, and I'm not even going to try to pronounce that name, somewhere in the Netherlands, covers 79 acres and contains 7 million flower bulbs. Does everybody know what a flower bulb is?
It's
Huh?
cooking.
That sounds good enough to me. A flower bulb is just what you plant in the ground. It's like the seed for the flower. About 30 gardeners work together each year to design the flower formations. How many bulbs do they use in each square yard? So that's what we're looking for, each square yard of the garden. Round your correct answer, round to the correct number of significant figures. And I put this in here just to help you out because I figure most of you probably don't have a clue. 1 acre equals about 4,840 square yards. Cooper probably knew that, right, Cooper? Liar. Huh? So if you knew that, you should know how many feet are in a mile then.
That's right. It's like 200.
200?
That's what I said. I said 200. It's 5,285 or something. Oh, and
80.
80. I was close.
Yeah, you were pretty close. All right, so on this, what we're going to do, we got 7 million flower bulbs. So this is what we're going to start off with, 7 million. Is that right? Is that enough zeros?
Yeah.
And we're going to divide it by, how many acres are there?
No, it's not.
Not right?
What? Yeah, it is. No, you're right.
How many acres are there?
79.
79.
79.
Somebody divide that for us. Do it on your calculator so you have it, so that because we're going to do something else with it. I'm not going to actually write it down.
88,607.5949.
So you got that answer on your calculator, right?
Yeah.
That's how many bulbs there are in each acre. They didn't want to know each acre, they wanted to know each square yard. So we're going to take that answer and divide it by 1 acre is how many square yards?
4.
So you already got this answer on your calculator.
18.
Divide it by 4840. And what's it come out to be?
18.3073.543. 543.
Now here again is where you got to use some common sense. We look back at all our numbers and we look at their significant figures and everything and doing all that. What are we trying to find?
How many bulbs do they use in each square yard?
So we got this square yard. A square yard looks like this. Each one of these little blocks here is 1 foot by 1 foot. That's a square yard. We're trying to figure out how many bulbs are planted in there. Well, if we're trying to figure out how many bulbs are in that square yard, is our answer going to be 18.3073 whatever? Is that going to make any sense?
Split a bulb into that.
Right, you're not going to split a bulb up just to plant it in there. So we're going to round this off to probably what?
18.
So probably about 18 bulbs. Again, using common sense sometimes when we're doing any of this significant figures or precision or rounding. Next one, cycling. Gemma is preparing for a 50-mile cycling race. She cycles an average of 19.7 miles per hour. How long will it take Gemma to complete the race? Round to the correct number of significant figures. How are we going to figure out how long it's going to take her?
Well,
Take 50 miles and do what to it?
I got it.
What do you do with the 50 miles?
Divide
Divide it
it.
by
19.7.
19.7. Now watch. Watch what happens here. 50, that's miles. This is miles per hour. What's gonna happen with the miles on top and the miles on bottom? They just cancel out, and that just leaves you with what? Hours. That's what our units are on our final answer. What is 50 divided by 19.7?
2.53807.07.
538, what?
07107.
So, now we want to round this off correctly. How many significant figures did this number have? The 50.
2,
2. How many did this one have?
3,
So we want how many in this one? If we're multiplying or dividing?
3.
3. That's what the rule tells us, right? So what are we going to do? How are we going to round this off?
2.54.
2.54, what was our units?
Hour.
Hours. So it should take her about 2.54 hours. Radius of the circle has this measurement. Somebody tell me, what is that measurement?
No. 7 point. Give it 6. Yeah.
7.6 centimeters? 7.5.
Yeah.
Now, we're going to be in a range there, right? If we're at 7.6, what's the smallest it could be? 7.55. What's the largest it could be? 7.65. Anybody remember what's the formula to find the area of a circle? Pi times
Radius squared.
radius squared. So we're going to do two different ones here. Have your calculators out so that you can help me. One of them is going to be, this is the area that we're looking at. We want the highest and the lowest it could be. What's pi times 7.55 squared? Pi times 7.55 squared.
23.719.
Say it again.
23.719.
Now let's round it off. How many places are we going to round it off to?
2.
So 23.72. That's the lowest it could be. The highest is going to be pi times 7.65 squared. Somebody help me out.
Sorry. Oh.
What? What's it give us?
Is that a?
7.65. Pi times 7.65 squared. Anybody's going to help us out so we can finish up? Because I think this is the last thing.
183.85.
Say it again.
183.85. I messed up the first one. I didn't square it.
183.85?
Yeah.
Yeah, let's go back to the first one. What should it be then?
179.08.
Change that on your paper.
Yeah, I
So-
did it, but I completely got it wrong.
So, we don't know the exact area of the circle, but we know that the area is between those two numbers. The assignment, this first part of the assignment, you did last time. This was from last time. So if you've got it done, then you don't have to do it, it's already done. We're just adding this part on.
You got it.
If I have it, then I'm gonna grab it here in a second and hand it back to you. While I'm looking